In this video we are going to look at the change of base formula that you can use when evaluating logarithms. And we're going to start off by looking at a specific example, and then I'd like to show you why this works. A lot of times in math we're just given formulas and we accept how they work, and sometimes we have to do that, but if we can understand why the formula works and where it comes from, it can really deepen our understanding and appreciation of math. Alright, so a specific example, let's say we are asked to find the log base 2 of 18. Well, the first inclination might be, let's just punch it in on our calculator. Most of the calculators, actually any calculator that I've seen, is going to have two different logs that you can use on your calculator. It's going to have a log button, and that log button is base 10, and that's called your common log. And then it's going to have another button that's going to look like ln, and what that is, hopefully you know, is the log base e, and that one is called your natural log. And these are the only buttons on our calculator that we have that can allow us to find the log of something if it's got a base 10 or a base e. So what do I do if it has a base 2? I can't punch it in and figure it out. I could try estimating. If I think to myself, well, let's see, the log base 2 of 18 is, I don't know what that is, so let's set it equal to x. Okay, what does that mean? What does log base 2 of 18 mean? It means 2 to some power is 18. And I'm not sure what that is, but I could estimate it. I know, let's see, I know 2 to the 4th power, 2 times 2 times 2 times 2 would be 16. And 2 to the 5th power then would be 32. So 2 to what power is 18 is going to be a little bit bigger than 4. I could punch into my calculator 2 to the 4.1 or 2 to the 4.2 and just go from there and see if I can estimate it. And that would be a good way to come up with a close estimate. But to get the exact answer, we have to change our base 2 to a different base that we can plug into our calculator, and that's what the change of base formula does for us. Alright, so we know that it's going to be a little bit bigger than 4, alright? We know that. Okay, so let's look at this change of base formula over here and see if we can use it to figure out log base 2 of 18. Alright, so this says log base a of n equals log base b of n over log base b of a. So our problem is log base 2 of 18. So a is 2 and n is 18. So if we substituted those in over here, we have log, now I got this b. What is this b? I got these b's over here. What are they? I don't know, because my original problem is log base 2 of 18. 2 is in the a spot, 18 is in the n spot, but where do I get these b's? The thing is, you can choose that b value to be whatever you want. Now remember, what's on your calculator? You're going to change this base to a base b. Well, what bases are on your calculator? You got base 10 and you've got base e. I'm going to put those in red to highlight those. You got base 10 and you got base e. So if I were you, I would choose this b value to be either 10 or e. And it won't matter which one you pick. Let's start off with base 10. Now, if it's log, I'm going to write the 10 for right now, but when you have a log base 10, you don't have to write the 10, and it still means 10. So if the base is not written in a logarithm, that means that it's base 10. That's your common log. Alright, so I have log base b, which I'm picking to be 10 because it's on my calculator, of n, which is 18. Okay, let's color code these right here. So this n is going to correspond to this n right here, which for us is 18, over log base b, which I have to pick the same base, which is going to be 10, of, let's pick, pink, how about that, of a. So this a value right here corresponds to this a value, which for us was this 2. And I'll underline this in green. That was our 18. So I have to put a 2 over here. So now, in order to figure out what the log base 2 of 18 is, I just have to take the log of 18 and divide it by the log of 2. Notice I didn't write the base because that's base 10. Alright, let's see if I can pull up a calculator here. Probably should have had this pulled up before. Now you're going to get to wait, there we go. Okay, there's our calculator. Edit, let's view, scientific. Okay, so here's my log button right here. So on this calculator, and yours may be different, probably a nicer one than this one, I can punch in 18 and log. So there's the log of 18. Now I want to divide that by the log of 2, so I'm going to hit divide 2 log. Now that's the log of 2. That's not my answer. I still have to hit equals. And I get 4.16 x equals 4.169. Is that what it was? 4.169. So let's just round that to 4.17, which is kind of what we expected. Over here, we estimated it was a little bit bigger than 4. All right, so that's your answer. And that's all there is to it. Okay, just plug those numbers in and punch it in. It's only a couple steps. Let's go ahead and see what would have happened if I would have chosen log base e. So let's say I did log base 2 of 18 equals log base e of 18. Now that has to go on the top. Whatever this n value is, that has to go on the top over log base e of 2. So remember, the log base e, that's your natural log. So that's going to equal the natural log of 18 over the natural log of 2. And it should come out to be 4.17 when we punch it in. Let's try it. Alright, so on this calculator, the natural log button is right here, ln. So I'm going to punch in 18 ln, that's the natural log of 18, divided by 2 natural log, that's the natural log of 2. Then I have to hit equals, and I get the same exact thing, 4.16 or 4.17. And that is all there is to it. So that equals approximately 4.17, and that's the answer. And that's how you use the change of base formula. That's all there is to it. Okay, so why does it work? Let's take a look here and see if we can figure out why it works. Show you why it works. If you're not interested in why it works, I guess you can hit stop and go off and solve all your change of base problems. Okay, let's go back to this problem, log base 2 18. And let's say I was going to figure this out a different way, and I set this equal to x, and then I changed it to its exponential form like that. Now, another way I can solve this, and you should know how to do this method also, is to take the log of both sides. Anytime you have a variable in an exponent, you want to take the log of both sides so you can get that variable out of the exponent. This is a property of logs, that when you have a log of something to a power, you can take that power and pull it out in front and multiply it by the log. So if I take the log of both sides, then I have x times the log of 2 equals the log of 18. And now if I want to solve for x, I divide both sides by log 2. Here I'm using log base 10 because I'm not writing a base. And I can cancel this log base or log of 2. And I end up with x equals log 18 over log 2, which is exactly what we got when we used the change of base formula. We got log base 10 of 18 over log base 10 of 2. So the change of base formula is just a shortcut, so you don't have to go through this to come up with the same exact thing. You don't have to take the log of both sides and pull the exponent down and divide both sides. It just takes you right to this spot right here. Okay, well, what if I did this same exact procedure without any numbers? So let's say I have log base a n. Let's keep it all in variables. I don't know what that is, so I set it equal to x. Now I'm going to do the same exact procedure that I did over here when I had values plugged in. I'm going to do that same procedure over here with log base a of n equals x and solve. I'm going to solve it and see what I come up with. So I would get a to the x equals n. That's exactly what I did over here first. Then the next thing I did was take the log of both sides. And let's just do, I did log base 10 over here, but you could take the log of any base you want. So I'm going to do log base b on both sides. I didn't leave myself a lot of room. Let me erase this so I can put that in there. So I'm going to do the log base b on this side of n. Okay. Now, from the rule we talked about a second ago, I can take this x and bring it out in front. So that would give me x times the log base b of a equals the log base b of n. Now this log base b of a, that seems like a whole bunch of variables swimming around, but what you need to remember is log base b of a is one number, and log base b of n is one number. It represents the exponent, b to what power is a. So think of all, I could even put this in parentheses to emphasize that point. That is one number, and that is one number. So if I want to solve for x, I need to divide by this number, log base b of a. Okay, so I'm going to divide both sides by log base b of a. Divide by log base b of a. What does that give me? That gives me x equals log base b of n over log base b of a. Sorry, I'm running out of room there. Hopefully that looks okay. Kind of looks like a 6. Let me write that a little bit better. Log, because this is sort of the grand finale here, log base b of n over log base b of a. So that equals x. Well, what was x when we started? Here it is right here. X was log base a of n. So x equals this expression, this fraction, and x equals log base a of n. So this equals log base a of n. And hopefully what you see there is we have our formula, our change of base formula. So we derived our change of base formula by simply changing the right-hand side. We set that equal to x, and then we changed it to exponential form, took the log of both sides, brought down the x, solved for x, and we derived our change of base formula. Now you don't have to know how to derive the change of base formula in order to use it. Once you have the formula, you just plug and chug, as they say. You just plug the numbers in and chug out your answer. But it's important to understand that these formulas come from somewhere, and they're derived from rules and properties that we have previously used. So this is probably a formula that you want to memorize or put in your toolbox of things that you can use to solve equations and help you simplify problems.